going through 1893?
नहीं सर,
किया कि नहीं किया?
किया स्टार्ट, आज एक पेज ही पढ़ा।
नहीं नहीं, वो वैसे ही है, 2 या 3 पेज, एक दिन में 2 या 3 पेज, नॉट मोर देन दैट। क्योंकि अगर
ओके
बहुत ज्यादा देखोगे ना तो समझ में नहीं आएगा।
यस सर।
Yeah, and start with that entire right from definition and go ahead with that. मतलब बाकी लोगों ने शुरू नहीं किया? Yes. What about you, समीर?
कर दिया सर।
शायद तुमने पहले से ही पढ़ना शुरू किया होगा। यू आर वर्किंग नो इन अ
नो सर।
so then someone of you was working in structure engineering firm, I think. Yes. What about you, Ketan?
यस सर।
शुरू किया कि नहीं?
यस सर, स्टार्ट किया, और ये भी पढ़ा था आज 13920। तो वो भी मतलब समझ रहा है, लेकिन वही अगर आप उसे एक्सप्लेन
अच्छा,
करोगे तो आप एक्सपीरियंस के साथ थोड़ा
नहीं,
मतलब वैसे समझने में इजी है वो
हम्म,
आईएस कोड, लेकिन आपके एक्सपीरियंस के साथ वो थोड़ा और अच्छा हो जाएगा।
See, you have to look into any clause with one aspect, that what is the use of this clause, why this clause is intended, and how this clause is helping the desired goal to achieve. Necessity, then what is the use of that, and if I do not follow this clause, what troubles I might face, or what troubles the structure might face because of violating that clause. So अगर ये 3 एस्पेक्ट से आप किसी क्लॉज को पढ़ना शुरू करेंगे ना, then you will understand the logic behind that clause. Just saying that okay, the code says B by D ratio shall not be less than 0.3, so I am using, so I am trying. But why? What will happen if that B by D ratio is less than 0.3? So that type of thought process you have to develop, and then you will understand why the code is saying. See, all those clauses, directly or indirectly, they are forcing you to go ahead with ductile detailing. मतलब सीधे सीधे हाथ से अब खाना नहीं खाएंगे ना, तो उल्टे हाथ से वो आपको वही खाना खिलाएंगे जो आपने रिजेक्ट किया है, बराबर?
यस सर।
And see, if you are violating one clause, then you will be getting trouble to fulfill the requirements of another clause. So finally, you have to fulfill that, and we'll see that through some examples why, what is the necessity of that, why it is you must follow it. All that we'll try to see. I'm not going through each and every clause, but I will try to create awareness about the clause as a practical structure engineer looks into that clause. Okay. Okay. Then let me
यस सर।
present. Yeah, let me present. So I'm sharing the desktop. Yes, Sulekha ma'am has also joined. Good evening, Sulekha ma'am. Hello. Am I audible to you?
Good evening, sir.
Good evening. Good evening. What time is there?
Yes, yes,
I
sir.
think maybe 5:30.
6, no, 6 o'clock.
6 o'clock. Okay. So
6 p.m., sir.
yeah, 6 p.m. Okay. Mhm. Okay, let us dive into straightway into that. So okay, let me see that it is somewhere here. This is 1893 and this is 13920. Okay. I think all of you maybe looking. Yeah, this is Indian Standard IS 13920 2016. So that means in the year 2016, the uh, recent development in that has been carried out. So you can see now. Let us see the. It is regarding ductile design and detailing of reinforced concrete structures subjected to seismic forces, and it's a code of practice as per IS uh, Indian standards. Okay, uh, that means this whole thing will be directing you how to detail the reinforced concrete structure which is subjected to seismic forces. That means it is not talking anything about how to calculate what are the seismic criteria, etc. All that you will get it in 1893. Okay. So ductile design and detailing. That means after your analysis, you will design the building, and for designing building, that means you will design the size of column, size of beam, then a layout, etc. Then you will give the reinforcement detailing and what will be the requirements for detailing. Clear? Yes or no?
Yes, sir.
Yes, sir.
So there is a basic difference between 1893 and 13920, because 1893 will let you know what are the codal provisions when you are supposed to create a structure for analysis for resisting the seismic forces. Okay, and this will give you after analysis with the help of codal provision of 1893. How you are going to design and detail the reinforced concrete structures as per ductile ductile facilities that you have to create. Because why ductile? Because 1893 says that you are reducing the response spectrum. That means you are designing your entire building for something around 1/5 to 1/7 uh, of the worst seismic that base year, when the severe earthquake will be the building will be subjected to that severe earthquake. The amount of base year that the building is supposed to resist will be reduced up to 1/5, and that means you are accepting some damage. You are allowing the building not to behave in elastic manner, and that's why you are going in elastoplastic region, and there the damages will come in picture. And to take care against those damages shall not be brittle. There will be you have to take care that the building is not going to collapse. That's why you are supposed to design the building for ductile detailing. Clear? So
Yes,
if
Clear,
you
sir.
yeah, so if you are using R equal to 5, then you have to follow all these codal provisions, because these, unless and until you follow these codal provisions, your building will not perform in a ductile manner. It may perform in any other manner, that is brittle. It may get collapsed because you're designing the building for lesser base shear. Clear?
yes, sir.
Yeah. And that is the first important thing, because I have seen lot of people, they are using R equal to 5, but they do not take care to design. Then they just follow the elastic manner design, where in elastic zone we say that the moment the force is removed, the building will come to its equilibrium position. That means there will be no damage. But here because of R equal to 5 or R equal to 3, whatever R that you are providing, you are making the design to in your assumptions is itself you are saying that okay, I'm not going to design the building to sustain or behave in elastic manner for 3 criteria. So in that minor criteria, if the building will be subjected to minor earthquake, then it will behave in elastic manner. When it will be going in moderate resisting moderate earthquake, then some sort of damages I am accepting. And even if it is supposed to resist the severe earthquake, then structural damage is also accepted, but collapse is prevented, right? Hello.
Yes, sir.
Yeah, and that's why there is a connection when the moment you use R equal to 5 in your calculation, you are supposed to follow all these codal provisions. Now you can go through the scope where you will see that this what is the scope, and you can see provision of this standard shall be adopted at in all lateral load resistance system of RC structure located in zone number 3, 4, and 5. That means the standard is optional in seismic zone 2. So in low seismic activity zone, code says that you may follow these standards, or depending on your situation, you may keep it optional. But in zone number 3, 4, and 5, you are bound to follow these codal provision. और अगर नहीं फॉलो किया तो क्या होगा? Code says we do not take any we do not prejudgment what will happen when the building will be subjected to moderate or severe earthquake. Building may perform in any haphazardous manner, and it may get subjected to collapse. Okay. Then you can see the provisions for RC structures given herein. You can read all these things. That is simple. And these are, again, I will say that these are the references. Along with all these references, you have to read these codal provisions. Okay. Now this terminology, and this is very important. People do not read it, but I don't know why. But you can see the first is about beam, and as per this standard, how the beam is defined. These are the members, generally horizontal. That doesn't mean that there may not be any other inclination type of beam. Generally horizontal, of moment resisting frames with flexural and shear actions. Yes, clear हुआ है इसका meaning?
Yes, sir.
Yes, sir.
That means even if I have a member something like this, and this member is subjected to such lateral forces, it will be considered as beam. Or let's say this is your beam. Now this beam is subjected to lateral forces, maybe of any type, and it is predominantly registered with for this flexural action and not for this axial load. Okay. Okay, now you can understand that. Then boundary element. Now these boundary elements are in shear walls, which are vertical. Will go into that, where these are the walls that are strengthened by longitudinal and transverse reinforcement. They may have the same thickness, or they may have additional extra thickness. That means if I say in plan, if I draw this as a shear wall, there will be a boundary element somewhere here, and there may be a boundary element somewhere here. So these are the two boundary elements. They may have a thickness as the thickness of wall, or they may have a more thickness. You may call this as a thickness of boundary element. Okay, this as a thickness of boundary element, or this you may have a thickness something like this. So now whether this thickness is to be increased or not, who will decide? A structural engineer in charge will decide. He may use the same thickness as the thickness of shear wall, or he may increase the thickness of boundary elements apart from whatever the thickness he is having. That means this will act just like a I-beam. Clear?
Yes, sir.
Sir.
Now, one more thing is that this is strengthened by longitudinal and transverse reinforcement. So you will see that if I'm having, it is something like this, and let's say this is my boundary element, then I will strengthen them with longitudinal. So these are the longitudinal bars, as well as there will be lateral stirrups, that is transverse reinforcement. So they are strengthened. Clear? So that's why it is called a boundary element. And the normally in most of the situations, boundary elements are having same thickness as the thickness of shear wall. Then you can see columns. These are the members, generally vertical, of the moment resisting frames with axial, flexural, and shearing actions. That means column will be subjected to axial force, it will be subjected to flexural action, and it will also be subjected to shearing action. All those members in the moment resisting frame will be considered as columns, and the members which are only subjected to flexural and shearing action will be considered as beams. Okay, then cover concrete, you can go through this transverse reinforcement, you can go through this. Now this gravity columns in building. Now you can say that all columns will carry the gravity loads. Then why it is? Now see, this is a special consideration, that it is a column which is not part of lateral load resisting system and designed only for force action, that is axial force, shear force, and bending moment due to gravity loads only. But it should be able to resist the gravity loads at lateral displacement imposed by the earthquake forces. So in high-rise structures, some columns you may consider only to resist the gravity loads. They are not part and parcel of lateral load resisting system. Clear? Or
Yes.
you need a bit explanation?
Yes, sir, we need.
Yes. See, this is your entire building. Let's say this is plan of your entire building. Then there will be some cores. You can say these are the cores. Okay, and there will be lateral some columns over here. Maybe some columns over. I'm just drawing some columns. Now all these periphery columns, along with this lateral load, this shear wall, and you will have a structure which is connected. So this inner core wall is connected to all these lateral load resisting system. Let's say it is connected, and there may be few columns maybe few columns. These are the columns, but I have a choice that I will say that these columns will resist only gravity loads. They are not going to resist any lateral load in this direction or in this direction, because lateral loads will be coming in the floor level, and this floor level with the connected beams, it will transfer the load on these lateral load system, vertical elements, these columns, then this wall. But these columns may not contribute to transfer any lateral load. They are good for gravity loads. They will transfer the gravity loads to the foundations, but they will not take part in the resisting system. So that is called gravity column. Clear?
Yes, sir.
Now the reason behind that,
Yes, sir.
the reason behind that, let's say you're having a 50-story structure, and if all the columns you're creating are subjected are supposed to resist the lateral loads, then the sizing of columns in inner columns will be very high, and that will obstruct your architectural use or access, etc. So the system is created such a way that these will be the gravity columns, and um, remaining columns will form only as a gravity load resisting system. So they will be of smaller size, but they will not contribute in resisting the lateral loads. All lateral loads will be resisted by the shear wall, inner outer periphery, or some columns which are supposed to resist them. So the moment resisting frame, now these columns does not have to resist the moments that are coming due to the lateral load, and that's why they are separated. So you can have a system like that, and that system is applied or used beautifully for designing that 110-story CS tower, and that was the first time the engineers come to know that yes, that can be uh, carried out. See what he has done in that 110-story structure CS tower. He has created some 9 cubicles like this. He has created some 9 cubicles. Just I am trying to show you it, but you can see. So these are the square. So all the columns which are coming in this line, this line, and any column inside this area or inside this area or inside this area, that column was not supposed to resist any lateral load resisting forces. So all that periphery of this, and this was something around 22.5 by 22.5. So huge area was available, and because of that, you can have a large opening in any of this. And this was a central core where that lift arrangement for various types of lift has been considered, and this core was connected to all periphery cubicles. So you can go and find out some geometrical concept in that 110-story CS tower. So the books are also available on net, or you can go through JD Butch. There is one more reference that I am giving you. the man called J.D. Butch.
सर वो आज शेयर हुई है सर ग्रुप जीमेल आईडी पे.
आज शेयर हुआ है. So you
Yes,
can
sir.
go, yeah, you can go through uh, this book. This book will see. We are not interested in finding out those complicated formulas and design. We are not going to design 110 story structure, but how that resisting system is created, you can go through that. And just if you have if you can go through entire book, you will find that structure engineering is very simple, and everyone can understand, provided you have that attitude. It does not need any rocket science. You should not, you need not be Einstein, but you can understand. And that's why we have shared that book by Dr. J.D. Butch. Okay. So there you will understand gravity columns and lateral load resisting system columns. And you can see here lateral force resisting system. It is the part of the structure system which participates in resisting forces induced by earthquake. Okay, so the members which are in this or vertical members which are the part of this lateral load resisting system, they are also a part of gravity load system. Okay, now the moment resisting system, you can see moment resisting frame. It is a three-dimensional structure system composed of interconnected members without structural walls, so as to function a complete self-contained unit width without the aid of horizontal diaphragm. So only the frame will take care of whatever lateral load resisting system, lateral loads they are coming to on that building. This horizontal and vertical bracing, or that you may call it as a frame, bare frame, it will take care how to resist those lateral loads without creating any bracing system. Okay, so that is called a moment resisting frame. Or you may say that whatever frames that you are using up till now, they are a simple moment resisting frame. And then there are some special moment resisting frames which will include that they are detailed, specially detailed to provide ductile behavior as per their requirement. That we'll see. Then this is one ordinary moment resisting frame. So moment resisting frames compose of two terms: special moment resisting frame and ordinary moment resisting frame. Now you may recall that while we were creating ETAB, let's say this was your floor, and we have given that diaphragm concept. And after creating diaphragm, you can say that this was something that ETAB was showing you, something like this. Yes.
Yes, sir.
So this is called a diaphragm, and when this diaphragm will be included, then it will be a special moment resisting frame. And if there is no diaphragm of such, then it will be ordinary moment resisting frame. Clear?
Yes, sir.
So one more thing is also there. Let's say in steel structures, you may say that this is your floor. Okay, and the floor is composed of such members, and many times you see that you're connecting it a diagonal brace system, something like this.
Yes, sir.
So this is called a brace system. So this is a horizontal bracing system which is resisting the lateral loads. Okay, and if you find it in vertical frame, let's say this is your vertical frame, and in vertical frame you are having a structure like this, and many times in steel structure you will see that such type of diagonal members are created. Now these diagonal members also resist the lateral forces in this direction. But this this bracing system will not resist forces in this direction. Are you getting it?
Yes, sir.
Then who will resist the forces in this direction? Then you will have to create one more frame, which will be something like this. So you can consider this as a 3D structure. So if the lateral forces are induced in this direction, then this frame will resist them. And if the forces are induced in this direction, then this frame will resist them. Clear?
Yes, sir.
So the lateral resisting system, whatever may be that, it will resist the lateral loads which are always in its plane. Okay. So the plane of bending and axis of bending, you must go through that. I think I have completed that also. Plane of bending.
Yes, sir.
See, if you have three axes, let's say this is your x axis, this is your y axis, and this is your z axis. So you will have three frames. So this will be your YZ plane. Okay. Then this will be your XZ plane, XY plane. So this will be your XY plane. And you can say that if I draw anything something like this will be your XZ plane. Clear? So
Clear, sir.
in the plane. Now,
Yes,
if I
sir.
say that, yes, see, if I say that YZ plane, then that YZ plane will resist the forces in this direction. Okay. Then XZ plane will resist the lateral loads in this direction, like that. Yes.
Yes, sir.
So that is in the plane. Okay. Then let us go ahead and see. Yeah, you can see here that is shear wall. It is a vertically oriented planar element that is primarily designed to resist lateral force effects, axial force, shear force, and bending moment in its own plane. This is very important. This is very important, in its own plane. Clear?
Yes, sir.
Yeah. We'll see when we'll be going through our ETAP model. We'll see that, and that time this in plane forces and out of plane forces you will come to know more. But I think I have discussed it while I was going through that ETAP tutorial. Okay, then special shear wall. Now it is a structural wall meeting special detailing requirements for ductile behavior. And that for that you have to go to this 10. So right now we are at 4. 3.11 says that if you want to see more about special shear wall, go to that 10 number note, and there you will find what is special shear wall. Okay, and then you can go through the symbols. And now starts your fifth as general specifications. Now just we'll go through basic things. What is mean by ductile? I think you know that what is the meaning of ductile. Yes. Yes. Anybody? What is the meaning of
Sir,
ductile?
So if we apply a force on the ductile material after
Okay.
elastic limit, it will gain its original shape if we remove the force.
That is elastic material. That is not ductile. That you are talking about elasticity, elastic
ओके
material.
सर, वो डक्टाइल में सर उसको इलोंगेट करके वायर की फॉर्म में हम शेप दे सकते हैं,
Yeah.
वो मटेरियल डक्टाइल होता है
Okay.
बेसिक।
Now let me give you a basic idea about ductile. See, you can go through the technical definition, but the concept behind is that let us say that a beam is overloaded. So what will happen? It will fail, right?
Yes,
Yes
sir.
or no?
Yes, sir.
It is much more overloaded than its capacity. Then the result is same, that it is going to fail. Now, how that beam is failing, that will determine whether that beam is ductile or not. So there are two ways: either the beam will fail in ductile manner, or the beam will fail in brittle manner. Okay, is this much clear?
यस सर।
So the failure pattern will decide whether it is ductile or not. So if you go on increasing the forces on a beam, definitely every beam has its capacity. Beyond its capacity, it cannot sustain. बराबर? Yes,
यस सर।
and that is the law of nature. मान लो कि अगर I am training you, let us say I went on giving you the session for one hour, 2 hour. Now you are having the capacity to bear that for 2 hours. But let's say 3 hour, 4 hour, 5 hour, the things are going. Finally, you will conclude and you will break, right? Now that breaking pattern will decide the quality. Now here I will say that when the beam is loaded beyond its capacity, it may suddenly break. If it is breaking suddenly, then you will say that it is failing in a brittle manner, that it is not giving any enough indication about its yielding process. Okay. Now another beam may start bending. Before failing, it may start bending, then it may start cracking, it may start giving you a noise, and maybe after two days, 3 days, finally it will fail. It will not fail suddenly. That means a failure which is sudden and catastrophic, that is called a brittle, and a failure which is giving you enough warning. Then a time, it is not sudden, it will give you enough warning, and it is not sudden, and it will start yielding before finally failing. Clear?
Yes, sir.
Now you must have understood what is the difference between ductile failure and brittle failure. Both are failures, 100%, because we are talking about failure. So both are failures, but in brittle failure, the things come suddenly. मान लो कि एक बिल्डिंग है और आपके आंखों के सामने देखते देखते वो बिल्डिंग कोलैप्स हो जाती है. That is called a brittle failure. And there will be another thing, that the building will start deflecting, building will start creating the noise, then beams may get fractured, bottoms and joints may start cracking, and it may go 3 years, 4 years, and finally it will break. That is called a ductile. Sorry, that is called a ductile. And that is why, as a structure engineer, I will always, देखिए फेलियर तो किसी को नहीं चाहिए, राइट?
Yes, sir.
बट अगर हो गया, क्योंकि सारी चीजें तो हमारे कंट्रोल में है नहीं, मगर अगर हो गया तो एटलीस्ट we'll try that under failure will suffer lesser, or at least there will be no human hazard. Maybe property hazard तो होगा, money hazard तो होगा, क्योंकि कुछ चीजें बनाई हुई चीजें गिरती है तो लॉस तो होता है, but loss in terms of property, in terms of money can be absorbed, but loss in terms of people inside the building cannot be you cannot absorb that. Okay, मान लो अगर बिल्डिंग गिरना मतलब बिल्डिंग स्टार्ट कर रही है, द slabs are starting vibrating, the plaster below the soffit or ceiling is started cracking, then beam started bending. Can you think that the people inside the building will stay over there? They will run away. Yes or no?
Yes, sir.
And they will have enough time to get away from that building along with their property and whatever valuables they may be having, because that building is not going to fail immediately. It may take the failure time may be prolonged, and it may take 15 days or 20 days. Then there could be some whether we can have any solution to resist that failure, etc. So we have a lot of time. That is called ductile failure. So as a structure engineer, we encourage the ductile failure rather than brittle failure. And this 13920 is all about, it is trying to create a failure pattern in ductile manner. Clear?
Yes, sir.
Now,
Clear, sir.
now you can imagine that if you have a chalk in your hand and you try to bend it, it gets break immediately. That is a brittle failure. And let's say you are having some sort of rod, and that rod you start bending, and then that rod gets bent, but it doesn't get cracked and in pieces. That is called a ductile failure. So we are trying to encourage ductile failure, and we prohibit the brittle failure through these codal provision. Clear?
Yes, sir.
Yes, sir.
Now you can see the general specification, the design and construction of reinforced concrete. Now, why reinforced concrete needs ductile detailing? Because concrete itself, as a material, concrete itself is a brittle material. Why you don't have any codal provision to have a ductile failure in terms for steel structures? Because steel itself is a ductile member. So if you are making a frame of steel structure, let's say columns and beams and bracing, etc., it is definitely a ductile structure. So it doesn't need any ductility to be added into it. Ductility it is to be added in reinforced concrete because concrete itself is a heterogeneous material, and that's why it is a brittle material and it will fail in brittle manner, and we don't want that. That's why we are making it a ductile behavior detailing, and that detailing is provided with the help of reinforcement. Clear? Now you can see the design and construction of reinforced concrete buildings shall be governed by provisions. ये तो पहला है 456 तो आपको यूज करना है, except as modified by provisions of this standard for those elements participating in lateral force resistance. That means gravity columns, you don't have to provide these ductile detailing. Okay. Okay, then you can see minimum grade that code has provided is M25 for buildings having height more than 15 meter in height in seismic zone 3, 4, and 5. That means in zone number 2, you can use M20. Clear?
Yes,
Yes
sir.
or no? Yeah. and then as per 456, वो तो आपका 456 का जो requirement है वो तो आपको करना है. अगर 456 में you design a building for grade of M20 and the building is having height more than 15 meter and it is located in zone number 3, 4, 5, it is not allowed. You have to go at least for M25. That is the meaning of this clause. Okay, then
Okay.
steel reinforcement resisting earthquake-induced forces in RC members and in boundary elements of RC structure wall shall comply. This will go to that clause and then we'll see. Now steel reinforcement use shall be. Now here you can see the reinforcement that you are using shall be Fe 415 or less, not more, conforming to IS 1786. And I have covered this also, and that is you can see here for grade Fe 500 and Fe 550, that is high strength deformed steel bars produced by thermomechanical treatment process having elongation more than 14.5% can be used. Otherwise, you have to go for less than 500. That means Fe 415. This is very important. So if you are using Fe 500 for your design for lateral load resisting structures, then you must have TMT bars. Clear?
Yes, sir.
Yeah, then actual 0.2%, you can read this. This is a little bit complicated, and unless you go through your stress and behavior of HYSD, you will not understand this 0.2%. Okay, anybody interested how this 0.2% is coming as a proof strength? Yes, anybody knows it?
No, sir.
हमने कभी उस पर सोचा ही नहीं.
नहीं, सर.
अब बताता हूँ क्या है. जानना चाहेंगे क्या छोड़ देंगे?
नहीं, बता दीजिए सर. अब इंटरव्यू क्या है?
जानना चाहेंगे सर.
ओके ओके, बताता हूँ थोड़ा. as you people are actually see all this whatever I am saying, I am not giving you any advanced structural knowledge. It is in our preliminary books. मगर हमने वो बुक्स का सही ढंग से कभी अप्लाई किया ही नहीं. सी in case of steel, if you go for your stress strain diagram, so this is sigma and this is epsilon. So how it was something like this. It was straight up to this, then it was having a bend like this, and then finally like this. Yes. So up to this, you can see it is following your elastic, so stress to strain is equal to constant, and that constant is equal to E, Young's modulus. Yes. So up to this point, so let's say somewhere here, so up to this, the if the bar is elongated in up to this, we call that the up to this it behaves linearly elastic, because this is a linear curve, and then up to this you will see that it is not behaving linearly. So this is a non-linear curve. It is not linear. It is not a straight line. It is some sort of parabola, and later on it gets reduced, and we say that this is our sigma y or Fy, whatever you call Fy. In structures we call it Fy, right? Hello.
Yes, sir.
Yes sir.
ये तो पढ़ा है ना बुक में, सिर्फ मीनिंग
Yes sir.
पता नहीं. See what happens if I stress the element up to this point, then you will see that this is my strain, and the moment I release the stress, then it will come to zero. It will come over here, zero, and that is what we call elasticity. the bar is subjected to tension, then it gets elongated, and the moment the tension is removed, it comes back to its elastic original position. Yes, Samir, this is what you were talking.
यस सर, वो कंफ्यूज हो गया था सर मैं.
हाँ, नहीं नहीं, होता है थोड़ा. कैसा है, जैसे जैसे आगे बढ़ते हैं वैसे होता है. मुझे थोड़ी पहली बार आया था, मुझे भी 10 बार गलती करने के बाद आया ना ध्यान में, तो होता है, कोई बात नहीं. बट ट्राई नाउ, इसके बाद आप कभी भूलेंगे नहीं. सो दिस इज कॉल्ड इलास्टिसिटी. ओके, द मोमेंट द फोर्सेस आर रिमूव्ड, द एलिमेंट कम्स बैक टू इट्स ओरिजिनल पोजिशन. So this property is valid up to this point, and that's why we call it as a yield point. What happens after this? Let's say I stress that element up to this point, and then I remove the force. What will happen? Will it come in this line?
नो सर.
No, it will return to this line. So this much will be permanent damage. This is permanent damage.
यस सर.
And by definition, this damage is considered as 0.002, or I will say 0.2%. And this is called proof stress, 0.2%. Yes?
यस सर. यस सर.
Yeah. And why we are defining this? Because this path is not defined, and it does not follow any rule. See, if I am having this and then suddenly this, then I can define this law. But it is coming something like this, and this is not parabolic, not cubic. It cannot be defined. So trial and error base पर इसका definition किया जा सकता है, and that's why it is called a non-linear, and it is not in any mathematical formulation. I cannot provide any even if the complicated form is there, I cannot find out a mathematical solution to represent this path, and that's why it is called non-linear and non-parabolic. And to define then what is the yield point, that's why after n number of tests, people have found that this is the permanent deformation that cannot be covered, right? And that is called a 0.2% proof. See, at this point, you were having a stress up to this. So this was your stress. And the moment you release the tension or you release the force, it came to this. But so this much is covered. This much is covered. So this is called a elastic recovery. This is called elastic recovery. Clear हुआ ना?
Yes, sir.
Yes, sir.
And whatever is this part, this part is called permanent loss or deformation, and that is equal to 0.002. And then you will see that this part represents by this 0.87 FY.
FY upon ES.
तो यही फॉर्मूला यूज करते हैं ना आप,
यस सर.
मगर अभी पता चला वो है क्या. So this is your elastic part, and this is your plastic part, which is not recoverable. So, and that means if you are using this 0.2% proof stress, that means you are saying that non-elastic or elastoplastic part is 0.002, and that's why we call it 0.2%. And this deformation is 0.87 FY over ES. Okay. ये क्लियर हुआ?
यस सर।
अभी दोबारा स्टील स्ट्रक्चर का या किसी रिइंफोर्स्ड कंक्रीट स्ट्रक्चर का बुक निकालना बेसिक, और उसमें ये कर्व देखना, और कर्व देखने के बाद आपको पता चलेगा अरे ये तो अब तक पता ही नहीं था। क्लियर?
सर
Okay, now you can see this, you can read now. I have covered all these things, 5.3.2 to 5.3.3. You can read and you can understand it. Then shall be included, and see what is happening over here. In RC frame buildings, lintel beam shall preferably not be integrated into the column to avoid a short column effect. When integrated, they shall be included in the analytical model for structural analysis. That means if you are having floor to floor height, maybe something around 4 meters, let's say, and somewhere at 2.1 or 2.4, you will be having your top of the door as well as the lintel level. And if you provide a lintel beam over there, it shall not be connected to the adjacent columns which are resisting, which are the part of lateral load resisting system. And if you connect them, then you will have to model it in your analysis model, whether you are using STAD or ETAB or any other software. You have to analysis that model, because that will create a short column effect. Now you will ask me what is the short column effect. Yes?
यस
Yes,
सर।
sir.
वो तो पता ही था. See, this is your structure. Let's say this is your floor to floor height. This is floor to floor height. And here you are having, let's say you are having a door, and here you provide a lintel beam which is connecting to these two columns. Then unbrace height will be this, and then unbrace height will be this. So this is called a short column. And when short column is there, what will happen? Yes, try to imagine. नहीं पता चला तो भी कोई बात नहीं, but try to imagine. नहीं तो ये पता नहीं चलेगा, ये behavior का आपको अंदाजा नहीं आएगा. What will happen? Let's say this is my one column where upper story I don't have upper story. This is my floor to floor height. But here, as I have provided one more beam, the height, this is the height of the column. Yes, and so the column is divided in two heights, H1 and H2. Because of that, what has happened? Socho. This column will be flexible because effective span to L by D ratio. Yes, because it will for the same cross section. See, I'm not changing the size of the column. So whatever is the size of column below the lintel, the same is above the lintel also. Yes or no?
सर
So this is your B and this is your D. Then L by D or L by B will be increased or decreased. See, L is decreased. That means L by
डिक्रीज हो
D.
जाएगा सर,
Yeah,
डिक्रीज होगा सर।
right. Now, because of that, this column becomes more rigid. this column becomes more rigid than this column. See, अगर ये छोटा कॉलम यहां से उसको बेंड किया तो इतना ही बेंड होगा ना, फॉर द सेम फोर्स P, राइट?
Yes, sir.
एंड ये बड़ा कॉलम है, फॉर द सेम फोर्स it will deform more. So if I call this delta 1 and this as delta 2, you will see that delta 2 will be more than delta 1. It will be more than 1. Yes,
Yes, sir.
Yes, sir.
that means this force is not that way registered by this long column, but it is registered by this column. तो जो रेजिस्ट करेगा उसको प्रेशर आएगा. Yes, yes or no? See,
Yes, sir.
when there will be stresses, when there will be opposed to the external pressure, then there will be a stress. Yes or no?
Yes, sir.
So because of the short length, this column is attracting more force. See, यहाँ पे VB आपका सेम है, ओके? VB तो पूरा बिल्डिंग का है. अब ये VB बोलता है भैया कौन कौन कितना कितना लेगा, तो ये कॉलम बोलता है यार मैं थोड़ा लूंगा क्योंकि मेरी हाइट ज्यादा है, तो मेरे पास रेजिस्टेंस कैपेसिटी कम है, तो I will contribute less. और ये कॉलम होता है ना, जितना है उतना लाओ, मैं I will try to resist क्योंकि I am strong. Yes.
Yes, sir.
So because of that short column, this is called a short column effect, and this short column effect comes in picture, and the columns are supposed to resist more lateral forces at that level, and because of that they get failed. So what you have to do? You don't have to connect them. See, in RC regular, we were here. In RC frame, lintel beam shall preferably not be integrated into the columns to avoid short column effect. अभी समझ में आया?
Yes, sir.
तो ये चीजें ऐसी नहीं समझती. When you have to think on it. कि बहुत दिन मुझे ये नहीं हुआ है, ये व्हाट इज दिस शॉर्ट कॉलम इफेक्ट. एक्चुअली शॉर्ट कॉलम है तो अच्छा है ना, इट विल रेजिस्ट मोर. नो, lateral load resist, it will attract more lateral force. क्योंकि total, let's say the building is subjected to, let's say 1000 kilonewton. Total base shear that the building is supposed to resist is 1000. तो ये शॉर्ट कॉलम वाले क्या बोलते हैं, अरे नहीं नहीं भैया उसमें से तो 500 हमारे पास ही भेजो, हम ही उसको रेजिस्ट करेंगे. यस, चेंज हो रहा है थोड़ा थोड़ा, समझ में आ रहा है?
Yes, sir. समझ आ रहा है.
Yes, sir.
Short columns are you have to make sure that your building configuration shall not create short columns, because short columns attract more lateral force, and they try to resist them locally. हमें ओवरऑल पिक्चर चाहिए. अगर वहां पे 100 columns है, see, the building will behave properly when all 100 columns are equally resisting the total VB. Let's say 1000. So every column will say that, okay, I will resist 10 kilonewton. The remaining 10 kilonewton will be registered by someone else. Yes, and together we are contributing to a resistance up to 1000 kilonewton. Clear?
Yes, sir.
या आप उसे ऐसा समझो कि आपके घर में एक शरारती बच्चा है और कोई खाना ला या कोई स्वीट डिश लाया तो अकेला ही वो सब ले लेता है, तो डिस्ट्रीब्यूशन प्रॉपर नहीं होता ना। अगर घर में 5 बच्चे हैं तो पांचों को थोड़ा थोड़ा मिलना चाहिए।
यस सर।
ये अकेला ही 70% लेके जाता है और बोलता है ये रिमेनिंग 30% ये बाकी लोगों को बांट दो, तो डिस्कम्फर्ट क्रिएट होता है।
यस सर, होता है।
The same logic you have to apply over here, that if in your building some short columns are created because of your ignorance about the registering system, then those short columns will create a local imbalance in the structure and they are bound to susceptible failure. Clear? अब
यस सर।
इससे आसान तरीके से नहीं समझा सकता हूं भैया मैं। यस अविनाश, हेलो,
Yes, sir.
समझ में आ रहा है कि नहीं?
Yes, sir.
सो द शॉर्ट कॉलम कभी क्रिएट नहीं करना है। डू नॉट क्रिएट create additional bracing at lintel level,
Okay, sir.
and this is
एक्सक्यूज मी सर।
yeah
सर अगर स्टेयर के केस में अगर सर जो मिड लैंडिंग बीम होगी सर, वो कॉलम को भी, वो भी तो सर शॉर्ट कॉलम में डिवाइड कर सकती है ना।
yes वो होती है ना, that is exactly what he is saying. Similarly, plinth beams were provided and staircase beams and slabs framing into columns shall be included in the analysis model for structural analysis. तो स्टेयरकेस के बीम उसके उस लेवल पर ही आपको मॉडल करने पड़ेंगे। क्लियर हुआ?
यस सर।
That is why in ETAB I don't go for that inclined slab. Actually, see in detailing what code has provided. Code says that, let's say this is your staircase. This is your staircase area. Okay. This is your mid landing. This is your landing, and let's say this is your going. Code recommends that this entire unit you have to make isolated from the rest of the building. Matlab, there has to be, let's say, this is a column, then I will create a expansion joint and I will have another column over here. This is column and I will have expansion joint and create another column, and this will be my building column. This will be my this will be my building frame beam, and this will be a beam required for staircase, and there will be a gap. So isolate, just like creating expansion joint. That is what recommended by code, but nobody follows.
It is not possible, sir.
अरे पॉसिबल सब होता है यार,
कॉस्ट बढ़ जाएगा सर, कॉस्ट
Yes.
बढ़ जाएगा।
तो बढ़ने दो ना, बिल्डिंग गिरने से कॉस्ट बढ़ना अच्छा है ना।
क्लाइंट भाग जाएगा सर, 4 ही कॉलम में तो कहता है कि आप अधिक कर दो।
नहीं राइट, नहीं मैं भी नहीं फॉलो करता हूँ, बट दैट सी हियर आई एम योर ट्रेनर एंड व्हाट हैज बीन suggested by code, I'm giving you that. Code says that all those structures, even if you are having ramp, because ramp is going in your building, let's say this is your slab and this is your another slab, and you are having a ramp something going like this. Yes,
Yes, sir.
it is something like this. Then there will be upper ramp and it is going something like this. Code says that these ramps also should be separated because these ramps create, see, a force here and there will be a force here. and they create imbalance in the entire structure. Code says that you have to make care, you have to take care that the ramp, staircase, all these units which are interconnecting one floor with another floor shall be preferably separated from the main structure. And that is what the code says, preferably. मतलब जितना हो सके कर लो, और नहीं हो सके जाओ, हम कुछ नहीं कर सकते. Okay, so exactly, Samir has questioned it rightly. The staircase beams. See what is happening. This is your floor, and this is your column, and you are having a mid landing over here, then a mid landing over here, and a floor over here. So you are creating a short column. Yes, these are two
Sir.
short columns. Yes or no?
Yes, sir.
Sir.
So in that case, one more thing is that, and that is exactly said over here. The staircase beams and slabs framing into the column shall be included in the analysis model, so that model will take care, and model will give you what are the additional or extra forces that are you are supposed to resist over there. Or one more alternative is there. You have to design that column, which is a short column, say twice the load, डबल उसका कैपेसिटी करो. मतलब if it is that column is subjected to, let's say, 300 kilonewton force along with some 30 kilonewton bending moment, then whatever reinforcement that you are getting, make it double. Yes.
Yes, sir.
अब अविनाश बोलेगा फिर भी सर वो अनइकोनॉमिकल होगा. अरे वो उसको थोड़ी पता नहीं, उसको बोलने का इतना लगता ही है. तुम्हें पता है तुमने डबल प्रोवाइड किया. एटलीस्ट मेक इट 50%. मेक इट 50%. whatever in those staircase design of those staircase columns which you are founding as a short column. Okay, we'll go ahead. Then RC regular moment resisting frame buildings shall have planar frames oriented along two principal plan directions. Oh, ये तो होता है, नहीं होता है ना, हमारे हाथ में थोड़ी है भैया. आर्किटेक्ट आपको बिल्डिंग ऐसी देता है. कहाँ है ये ऐसी बिल्डिंग?
क्रिटिकल बिल्डिंग है सर, इसको डिजाइन करने में ये टाइम हालत खराब हो जाएगा.
ऐसी बिल्डिंग कहाँ है? फेमस बिल्डिंग है ये.
मुझे नहीं पता सर.
Burj Khalifa.
Yes.
Burj Khalifa.
Yes, you are 100% right. Burj Khalifa. But let me.
उसमें हल्का सा कर्व
नहीं, वो
शेप
तो
है
है.
थोड़ा.
मैं एक अप्रोक्सीमेट शेप निकाला हूँ.
यस.
सी उसने उसने ऐसा ऐसा ऐड किया है. जिसकी वजह से वो बिल्डिंग का आर्किटेक्चरल बेहतरीन दिखाई देता है. ये ऐसा गोल गोल हो जाता है. मतलब ये है तो उसके बाद ये है, उसके बाद ये है, उसके बाद ये है, उसके बाद ये है,
यस.
ऐसा 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 ऊपर जाता है. But these are complicated structures. But let me tell you one thing. Even if this building is irregular, this building is not subjected to any type of torsion. अब आप बोलो कैसे उन्होंने टॉर्शन निकाला होगा. हमें तो रेक्टेंगुलर बिल्डिंग का टॉर्शन निकालना नहीं आता है. But they have designed it in such a manner, the structural configuration is such a fantastic that this building is not at all subjected to any torsion. अगर ये बिल्डिंग टॉर्शन में जाती थी ना तो इसके बनने के पहले गिरने के चांसेस ज्यादा होते थे. But that is different thing. But these challenges are there. But right now we are just going through the basics, and these are normally irregularities has to be avoided, and if then these listed irregularities perform poorly during earthquake. Why it is to be avoided? Because whenever such type of structures are subjected to lateral resistance system, they perform poorly. Poorly means you may say they do not perform as per whatever is in your mind, that uh, ductile behavior. It is 100% brittle behavior, and suddenly some part or entire building is uh, collapsed, or if it is not collapsed, because that collapse depends again the intensity of earthquake. If the minor earthquake is there, every building is going to perform in elastic zone, so no problem. But in terms of major and severe earthquake, that behavior is cannot be predicted. I'm not saying that it will fail. I will say that the behavior of that building under such uh, uh, moderate or heavy lateral forces due to seismic activity, the performance or the behavior or deformation performance of the building cannot be predicted. वो बहुत complicated है, और as a civil engineer we don't like complications. We are very simple people. We make the things simple, we analyze the things simple, and we live in simple things. uh, and always yeah, make a mind that you're not going to create 1 minute. सर फोन करू का नंतर? मी करतो. हो. Okay, so that is again a different issue, but let us go through some simple things. So these how to come across these irregularities, you will understand only when you start designing simple structures. अब सिंपल स्ट्रक्चर ही नहीं आता तो कॉम्प्लिकेटेड में कहाँ जाएंगे ना?
Yes,
यस.
sir.
हाँ, तो पहले अटेम्प्ट हमारा ये रहेगा कि लेट अस गो विथ सिंपल थिंग्स. Okay, then you can go through this beams general. Now again you can see over here, requirement of this section shall apply to beams, and you can see that to beams resisting earthquake induced effect in which the factored axial compressive stress does not exceed 0.08 FCK. Now what is the meaning of this? Anybody? सोचना पड़ेगा ये इसका मीनिंग क्या है एक्चुअली. और जब नहीं समझता है ना तो पिक्चर निकाल के सोचने का अटेम्प्ट करना, शायद आपको क्लियर हो जाएगा, शायद नहीं क्लियर हो जाएगा, मगर ये अटेम्प्ट करते करते आप यू विल स्टार्ट developing yourself as a structure engineer. See, this is beam, and now what this clause is saying that earthquake induced effect in which the factored axial compressive stress. Okay, that means the force is applied like this. Okay, and let's say this is my force P, and this is P, and it is acting in compression. Okay, then now again he is saying that compressive stress. Okay, that compressive stress means I don't have to apply force, I have to apply stress. That means I have to divide it by P by A, where A is this area. Clear हुआ? See how I am solving the problem. Yes.
Yes, sir.
Yes, sir.
Now I understood that factored axial compressive. Okay, factored axial compressive means it is 1.5 sigma C. Okay, does not exceed. That means it should not exceed what? 0.08 FCK. 0.08 FCK. Now you can see this is indirectly saying that the beams are not supposed to resist axial forces. Clear हुआ?
Yes, sir.
See, let us consider this equal to 25. Okay. Now 25 multiplied by 8 by 100. That is 0.08. So 25 divided by, so 4
Two.
into 2. Now what is this 2? 2 Newton per mm square, because FCK is in mm square. Yes.
Yes, sir.
Yes, sir.
Now he is saying that 1.5 sigma C shall not be more than 2 kilonewton. That means what? Sigma C shall not be more than 2 divided by 1.5. That means what? Yes,
1.33.
1.33. So finally he is saying that P shall not exceed 1.3, let's say 3 B into D. Right? That means very,
Yes.
very little. That means very, very little axial force. Clear?
Yes,
Clear,
sir.
sir.
So this is how you have to read the clauses. Finally, indirectly, what he is saying that भैया आपका beam है ना, the beam should, and now go back and see the definition of beam. The beams are the members which are subjected to flexural and shear forces and not axial forces. Now indirectly he is giving you that in this way, अगर वहां पे एक्सियल फोर्स है तो उसका अमाउंट बहुत कम होना चाहिए. अब मान लो ये सर ये तो हमारे हाथ में थोड़ी है, वो तो एनालिसिस से आएगा. अब व्हाट विल हैपन if your sigma C or whatever that factored axial compressive stress exceeds this 0.08 FCK, क्या करना पड़ेगा? क्या करें? Increase the size.
Yes, sir.
Yes. साइज भी क्लाइंट अलाउ नहीं कर रहा है, आर्किटेक्ट अलाउ नहीं कर रहा है. अरे क्या करते हो यार, मुझे इसमें ही बिठा दो. तो क्या करना पड़ेगा? Find out the way so that that axial force on that beam we shifted somewhere by some arrangement, by some your structural arrangement in your layout. अब वो भी पॉसिबल नहीं है तो क्या करना है? डिजाइन दैट मेंबर एज अ कॉलम. सिंपल. यस.
Yes, sir.
क्लियर हो रहा है ना? हाउ?
Clear, sir.
अब ऐसे सोचा था कि एक क्लॉजेस पढ़ते समय
No, sir.
तो ऐसा सोचना पड़ेगा, तब आप स्ट्रक्चर इंजीनियर बनोगे. कोई बात नहीं, मैंने आपको शुरू तो करके दिया. अभी हमेशा आप ऐसे सोचे. सी ऑलवेज गो अहेड एंड ट्राई टू सी एंड ये बताना क्या चाह रहा है मुझे. व्हाई इज सेइंग, ये कहाँ से लाया 0.08 FC के, और इसका और वो ये क्या है फैक्टर्ड एक्सियल कॉम्प्रेसिव से, वो क्या है ये टर्म क्या है? तो बुक्स में आपको पता चलेगा ना व्हाट इज एक्सियल कॉम्प्रेसिव स्ट्रेस, नहीं पता चलेगा,
हाँ
चलेगा
सर,
कि
यस
नहीं?
सर, यस सर।
हाँ, मगर आप ढूंढेंगे कब? व्हेन दैट क्वेश्चन विल राइज इन योर माइंड। अदरवाइज आप बोलेंगे "हाँ, चलो है वो क्लॉज, रहने दो, क्या करेंगे"। मेरे एक सीनियर ने मुझे बोला था यार, उसके एनालिसिस में ऐसा ही हुआ था, और यार नहीं यार क्या करेंगे यार, वो कोड तो क्या है, वो क्लॉज ही गलत है। मैं बोला क्लॉज नहीं गलत भैया, ट्राई टू इंक्रीज द साइज। नहीं बोले वो साइज बढ़ाना भी पॉसिबल नहीं है, लोग पहले से ही बॉम्बा बॉम्ब कर रहे हैं यार, बीम का साइजेस बड़ा है। मैं बोला फिर उसको डिजाइन करना कॉलम जैसा, वो बीम के लिए बोल रहा है ना, डिजाइन इट एज अ कॉलम, एक्सियल फोर्स विथ lateral moment and shear force। कॉलम तो हम उसी को डिजाइन कर देना, यूज दैट पीएम डायग्राम एंड डिजाइन द reinforcement into it, apply the reinforcement all along the periphery of the beam, that's all। अरे बोले ये तो मेरे ध्यान में नहीं आया था। होता है,
यस सर।
yeah। So you can find the solution, and don't consider all these clauses in negative manner, क्योंकि क्लॉजेस का कुछ महत्व है इसीलिए दिए है। एनीवे, बीम शैल प्रेफरेबली हैव विड्थ टू डेप्थ रेशियो नॉट मोर देन 0.3। क्या है? बी बाय डी। See what he is saying, beam shall preferably have width to depth ratio more than, that means shall not be less than 0.3। हम लोग क्या करते, बीम का विड्थ पहले डिफाइन करते हैं, ये तो हो गया, या कुछ लोग ये लेते होंगे,
यस सर।
और बहुत कम लोग ये लेते होंगे।
बिल्कुल।
ये तो लेते ही नहीं लोग, और बोलते हैं नहीं नहीं इसमें ही देखो, क्योंकि आर्किटेक्ट का प्रेशर है। नहीं नहीं, डोंट गो बियॉन्ड 200, डोंट गो 230 या 300 इज नॉट, मेरा दिखाई देगा ये इधर बाहर आएगा उधर बाहर आएगा, बाद में उसका सेल्फ वगैरह वो सब होता है, वो छिप जाता है, वो नहीं नहीं, वो डेप्थ बढ़ाओ। अल्टरनेट सॉल्यूशन क्या, आप क्या कहते हैं ना? नहीं सर, वो बीम का विड्थ बढ़ाना पड़ता है क्योंकि कैपेसिटी एक्सीड हो रहा है। तो बोले नहीं नहीं, फिर डेप्थ बढ़ाओ। कितना बढ़ाओगे? इसीलिए यहाँ पे आपको अपर अपर सर्किट लगा दिया कोड ने। बोले आप कुछ भी करेंगे, आप क्या करेंगे? 200/1000, क्योंकि इसको तो कोई ऑब्जेक्शन नहीं ले रहा, ऑब्जेक्शन इस पर है। यस,
डेप्थ बढ़ा देंगे।
230/1200 नहीं दो तो क्या होगा? ये दिखाई देगा ऐसा। यस, यस और नो?
यस सर।
ऐसा दिखाई देगा।
यस सर।
अब यहाँ पे देखो वो क्या बोल रहा है, बी shall not be less than 0.3 डी। तो आपका डी कितना है? 1000। ओके, मल्टीप्लाइड बाय 3 कितना हो गया? 300। डी shall not be less than 300। अगर आपको ये डेप्थ चाहिए तो ये नहीं चलेगा, आपको क्या करना पड़ेगा? 300। आर यू गेटिंग इट?
यस सर।
सर
In another way, code is restricting your D with respect to your B। क्लियर?
क्लियर सर।
अच्छा, क्यों कर रहे हैं ऐसा? शैलो बीम, 1 minute. सर फोन कर दो. हाँ. ओके ओके ठीक. Okay. So see what will happen if I make a slender structure something like this. Okay, in this direction it is okay. But as you are creating a 3D structure, what will happen if it is the forces are coming in this? It will bend something like this. Clear?
Yes, sir.
So that's why the code says that भैया ये D जो है ना इसके proportion में ये आपको ऐसा करना पड़ेगा. बढ़ाओ उसको, या तो इसको बढ़ाओ या फिर इसको घटाओ, मर्जी तुम्हारी. So indirectly code is taking care by giving you this restriction. B by D shall not be less than. I'm saying shall not be less than. Code says that preferably have width to depth ratio more than 0.3. Or you can say B is equal to more than 0.3D. और ये क्राइटेरिया हमारे यहाँ ही है, यूरोप में नहीं. यूरोप पीपल दे गो फॉर दिस आल्सो. जैसे नथिंग डूइंग, हम फॉल सीलिंग करेंगे. हाँ,
Yes, sir.
Yes, sir.
ये यूरोप, इवन गल्फ पीपल आल्सो, their minimum dimension is 300. Minimum dimension is 300. So they don't have this problem. This is a problem only in India, जहाँ पे हमको हर कुछ हिडन चाहिए. हिडन बीम
Complicated.
या
Complicated है सर.
नहीं कॉम्प्लिकेटेड नहीं, वो सही ढंग से दिमाग चलाते नहीं है ना. गलत ढंग से दिमाग चलाने में ज्यादा होशियार है. एनीवे, सो बीम शैल नॉट हैव विड्थ लेस देन. अगेन सेम, ये दोनों सेम ही है. कोऑर्डिनेट डायरेक्टली आपको बोला है भैया 200 से नीचे, क्योंकि कुछ आर्किटेक्ट है आपको 150 वाइड बीम पूछते. दे आर आस्किंग फॉर 150 वाइड बीम. अभी ये 150 में टॉप बार यहाँ पे, बॉटम बार यहाँ पे, और ये स्टीयरअप, राइट. कैसे होगा? Try to imagine, try to draw the sketch 150 by 450 and try to introduce four number of or 3 number of 16 dia bar at bottom and 3 number of 12 dia bar at top, and see what is happening. You don't get any lever arm at all. मगर नहीं, हम समझते नहीं. सो सीधा कोड ने बोला नथिंग डूइंग, 200 तो चाहिए. और दूसरा ये, तो 200 से क्या होगा? I can go only 200 by 600, right? Cannot go beyond 600, even 750. 200 by 750. Find out B by D ratio and check it over here. यहाँ पे फेल हो जाता है. Clear?
Clear, sir.
Yeah. Again, this beam shall not have depth D more than 1/4 of clear span. This may not apply to floor beams. Okay, this elevator. Now again the same thing. This is your span. This is your beam, and this is your span. Let us say the span is 3 meters. Yes, are you getting it? Hello.
Yes,
Yes,
sir.
sir.
Now this beam this beam is supposed to behave in this manner, flexural beam. तो उसका बेंडिंग मोमेंट ऐसा होना चाहिए, तो उसके लिए ये बेंड होना चाहिए ना. यस. अब ये बीम का मैंने डेप्थ मान लो, डेप्थ मैंने 1000 दिया, तो दिस इज 1000. Okay, let's say this is 300, or let's say 350, so that B by D ratio is created. So 350 by 1000, what will happen? आपको क्या लगता है, ये बीम बेंड होगा? Yes.
No, sir.
See, this will bend. This will bend. Okay, this will bend like this. Let's say this is continuous. This is continuous, so it will bend like this. But what will happen if I am having this span, but the depth is much, and I am having a support over here and support over here, and it is loaded? Is it going to bend? It is going to shear. ये shear हो जाएगा, bend नहीं होगा. Yes, because I for this is much more higher. BD cube by 12. So code says that this L by 4, so 3 by 4. So how much it is coming out to be? 750. Yes. So D more than 1/4. Beam shall not have depth more than 1/4. Kyunki if the beams are having a depth more than 1/4, then there is less chance the beam going to deflect, rather than it will go in a shear failure mechanism, and shear failure mechanism is brittle mechanism, and we want to encourage ductile behavior. And if we are going to provide 750, then how the ductile behavior will come in picture? Yes. Hello.
यस सर.
तो मोमेंट ऑफ इनर्शिया कम हो जाएगा.
नहीं यार, डी बढ़ गया तो मोमेंट ऑफ इनर्शिया ज्यादा हो जाएगा, उसकी वजह से उसका फ्लेक्चरल स्ट्रेंथ ज्यादा होगा और शियर स्ट्रेंथ कम होगा. And it will, see, I will say that try to imagine a thing that you are having a scale with width perpendicular to the loading. Will it bend? Or let me draw.
नो सर.
See, this is my scale. This is my scale. And I'm applying a load over here. So it will bend. Yes.
Yes, sir.
And
Yes, sir.
let us draw another picture. The same scale. Yes. Support and load. ये bend होगा?
No, sir.
नो सर.
It will need, वो bend होने के पहले ये shear होगा. Yes.
Yes, sir.
And what we are doing, the basic idea is that we want to encourage flexure and we want to decelerate the action of torsion, action of
Yes.
shear, right? Clear?
Yes, sir.
Hello.
Yes, sir.
Now the problem, where is the problem? Let's say you are having a structure something like this. Okay. So you are having a column over here, you are having a column over here, you are having a column over here. Let's say it's a hostel building with this passage, and this is a room, this is a room, this is a room, this is a room, and this is a passage, and you're creating columns. Yes. Hello.
Yes, sir.
Now we are having the same depth. Let's say this is 5 meter, this is 5 meter, and this is let's say 1.5 meter. So for 5 meter span, you may be needing something around say 600 depth. So you are providing a 600 depth over here for beams. So this is a problem, because now 1500 divided by 600 or 600 L by 4.
By 4.
So it is it is not as per the clause. So what you will do? अब आप इसका डेप्थ कम भी नहीं कर सकते, क्योंकि कंटिन्यूटी के हिसाब से whatever is the moment of inertia over here, the same moment of inertia has to be here. Otherwise, your reinforcement, whatever that extra for hogging bending moment, you cannot provide. तो डेप्थ भी आपको सेम लगेगा. Yes or no?
Yes, sir.
So in that case, avoid this column. जरूरत नहीं है ना, ये 7.5 स्पैन ले लो और ये 5 ले लो ना.
Sir.
Clear,
sir.
So this is the basic thing that as a structure engineer, right in the beginning, you have to create, so that you will not fall in the traps. Actually, these are not traps. These are the guiding lines how you should develop your supporting structure. क्योंकि 4 कॉलम किसने लिए? आपने लिए ना? Yes.
Sir.
तो 4 के 3 हो सकते हैं ना. The one span will be 7.5, another span will be 5. You can design the 2 span continuous beam. Why you need additional column over there?
Yes, sir.
That is how you have to develop your structural framing ideas before going for any calculation. यहाँ पे हमने कुछ calculation नहीं किया. We have not found any loading due to slab, dead load, live load. We have not done anything. But right in the beginning, we say that ये problem आ जाएगा. Remove that column. Not required. So we'll design the beam for 7.5. Not 7.5. Actually, it's 6.5. 5 plus 1.5. So it's a 6.5. So we'll design that for 6.5. Another beam for 5. That will take care of everything. So I think with this, I will conclude today's session. And I think we need a little bit one additional session so that I can go through this. But today I went through the basic ideas, and that's why. And I think these ideas, nobody will tell you. Everybody will just say that follow the code, and you will say that sir code follow किया तो design ही नहीं होता है. बराबर है ना?
Yes, sir.
Yes, sir.
होता है अगर आप सही ढंग से प्लान करोगे, सही ढंग से और प्रॉपर एक्शन लेंगे, तो you will see that you are following the code and even then your design is economical. मैं बार बार ये चीजें आपको इसलिए कह रहा हूँ, आई डोंट नो व्हाट इज हैपनिंग इन आउटसाइड इंडिया, बट इन इंडिया people are having some vague idea in their mind that code has some methodological ways and they don't know what is going in practice. ऐसा नहीं है भैया, आपको अगर इतना समझने लगा 5-10 साल के एक्सपीरियंस से या 20 साल के एक्सपीरियंस से, तो मैं आपको ये सिर्फ ये नीचे आई विल शो यू द लिस्ट ऑफ पीपल who have developed this code or they have gone through. You can see this.
Yes, sir.
Association of Consulting Civil Engineers, Bangalore. Atomic Energy Regulatory Board, Mumbai. Bharat Heavy Electricals Limited, New Delhi. Building Materials and Technology Promoting Council, New Delhi. CSIR, Central Building Research Institute, Roorkee. और ये सब सारे डॉक्टर है, ऐसा कोई लल्लू पंजू नहीं है यहाँ पे. CSI, CSR स्ट्रक्चर इंजीनियरिंग सेंटर, चेन्नई. देखो, सेंट्रल सॉइल्स एंड मटेरियल्स रिसर्च स्टेशन, न्यू दिल्ली. सेंट्रल वाटर कमीशन. और दीज आर द हेड्स ऑफ दीज इंस्टीट्यूट. ऐसा नहीं है कि वहां पे कुछ जूनियर इंजीनियर का काम करते, दे आर द हेड. क्रिएटिव डिजाइन कंसल्टेंट एंड इंजीनियर्स प्राइवेट लिमिटेड, तो प्रैक्टिस के लोग भी है. डीकेट टेक्नोलॉजीज, न्यू दिल्ली. डीडीएफ कंसल्टेंट्स. डायरेक्टर जनरल ऑफ बॉर्डर रोड्स, ये तो मिलिट्री वाले लोग हैं, बॉर्डर के रोड बनाने वाले. इंजीनियर्स इंडिया लिमिटेड, अ गवर्नमेंट ओन्ड कंपनी. Gammon India Limited, Mumbai, commercial organization. Geological Survey of India. Housing and Urban Development Corporation, chief of that. Indian Concrete Institute, Chennai. अब ये लोगों के पास एक्सपीरियंस नहीं है, सारा एक्सपीरियंस हमारे पास ही है. एंड व्हाट वी से, नहीं यार, ये लोगों ने कभी डिजाइन किया है क्या? कुछ भी लिखते परेशान करते, कोड फॉलो किया तो डिजाइन ही नहीं होता है, वो कोड का कुछ फायदा नहीं, कुछ नहीं, प्रैक्टिकल नहीं, ओनली थियोरेटिकल है. ये CVR मूर्ति, ये डॉक्टर CVR मूर्ति, हु इज द हेड ऑफ दिस एंटायर टीम. ये जो लोग हैं ना, ये अब इन लोगों से ज्यादा हमें आता है.
नहीं सर.
और सर,
बट वी कमेंट, नहीं वो कोड वालों को कुछ समझता नहीं. समझने का ठेका हमारे पास है और किसी के पास नहीं. बराबर ना?
Yes, sir.
So just get rid of that hypothetical concept. People say that code has been written by the people who do not have a practice.
Practical knowledge.
ये प्रैक्टिसिंग नहीं है लोग. ये आपको क्या लगता है? ये लोग प्रैक्टिसिंग नहीं है. वहाँ पे विमला अल्पना सेट, let me see that. It's somewhere. Yeah, this Engineers India Limited. Where is that? Yeah, Ela Das and one more. I know that Alpana. I'm not getting it. Yeah. Anyway, मैं इतना ही कहना चाहता हूँ कि there are these committee members are also from the reputed consulting firms from India. They are also from central government departments, military departments, and R&D people, then survey India people, urban development people. So IITs. So don't be under that impression कि नहीं कोड वालों को क्या मालूम कैसे डिजाइन करते हैं। लोग बोलते हैं,
Yes, sir.
डू यू एग्री विथ मी?
Yes, sir. Yes, sir.
मार्केट में बोलते हैं लोग, यार कोड कोड वालों ने कभी डिजाइन किया है क्या, कुछ भी लिखते हैं, वो प्रैक्टिकेबल नहीं है। तो प्रैक्टिकेबल सिर्फ हम लोग जो करते हैं, गलत। Okay, we'll go through this in next session, and then we'll go with our practical model, and then. But I think this was required, or या ऐसा रीड किया था क्या? Anybody? Hello.
किया था सर, बट आपने ज्यादा क्लियर कर दिया सर। अब सर एक वो आइडिया मिल गया कि आगे कैसे मतलब वर्कआउट करना है, इस चीज पे कैसे पढ़ना है।
Yes, yes. That was actually the intention behind this going through this codal provision. My intention was only that कि I want to create the eyes how we can look at the things, and with positive aspect, not with that लोग कुछ भी कहते हैं यार, I don't agree with that. आपने ये तो कमेंट सुना होगा बहुत सारे लोगों से
Yes, sir. Yes, sir.
कि कोड वालों को प्रैक्टिकल नॉलेज नहीं है।
सर अहमदाबाद के अंदर सब कोड ही फॉलो करते हैं, पागल की तरह कोड 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 फॉलो करते रहते हैं। सर प्रैक्टिकल चीज में ये फॉलो करते हैं।
हाँ,
प्रैक्टिकल चीज में ऑन साइट पर कोड फॉलो करते हैं।
नहीं, दैट इज द राइट प्रोसीजर, दैट इज द राइट प्रोसीजर। और वो क्यों हुआ है मालूम है? 2001 में उनको बहुत बड़ा झटका लगा है, उसके बाद वो बोले नहीं भैया अब नहीं, एक बार हो गया। समझ में आया ना?
यस सर।
कैसे होता है, जिसका घर जलता है ना उसी को समझ में आता है कि घर जलता है तो कैसा लगता है।
ये तो है सर।
हाँ, तो उनका बहुत बुरी तरह जला है। और दैट टू वन मोर थिंग इज देयर, 2001 में वहां पे मोदी जी ने वो सारा सर्वे लेके बोले नथिंग डूइंग। 2001 के बाद अगर कुछ दिखा, ये शॉर्ट कॉलम इफेक्ट जो मैंने बताया ना,
हाँ, sir.
major building, 40% buildings were failed because of that short column effect. आगे भी देखेंगे the failures, and if you go through that GSDMA has a lot of literature they have published for the finding the failures, and you can go through all that and you will understand कि जरूरी है। even if the codal provisions might find you very stringent, but that is required, or particularly when you are going for the structures more than 5-story and 7-story, then that is really important. Okay, then with this we'll conclude today's session, and I think tomorrow also we'll go ahead with that, right?
Okay.
Okay.
यस सर।
Okay, so tomorrow at 7:30 we'll again meet and we'll see the remaining clause. But now I will just go through all that and start thinking the process behind that, and you will understood. आज नहीं तो 1-2 साल में आप भी समझ जाओगे यार, ऐसा कुछ बहुत बड़ा बात नहीं है वो। एटीट्यूड डेवलप होना चाहिए, दैट्स ऑल। ओके,
Okay, good night, sir.
देन गुड नाइट।
Good night, sir.
गुड नाइट, गुड
गुड
नाइट,
नाइट सर।
गुड नाइट सर, थैंक यू सर।
Thank you, sir.
यस।